All right, so what are the basics of lines and angles? And of course, we start off with a lot of vocabulary because most students in geometry do. Lines that are coplanar and do not intersect are parallel lines. Our symbol looks like the double lowercase l in parallel. When you draw parallel lines, you have to mark them as parallel. It's not enough for them to look parallel. And we use a little caret going the same direction on each line to mark them as parallel. If I had another set of lines in the exact same diagram that were parallel, I would use 2 carets on it. And if I had a third set, I'd use 3 carets. By the time you get beyond 4 carets, your diagram's unreadable. I suggest you break out the colors. There are lines that are not coplanar and do not intersect. So we're talking 3-dimensional lines. Any ideas? Skew lines. I just like the word. Okay? There isn't one. No symbol for skew lines. I would write none. Okay. Usually when we draw skew lines, we use a rectangular prism to give that idea of 3 dimensions. So we'll start off with a rectangular prism to give the person who's looking at our work the idea that we've got 3 dimensions going on. And then we'll mark 2 of the lines that happen to be skewed to each other. Now it looks in my drawing like those lines are going to intersect. Okay, but this is like the line where the wall meets the floor in the front of the room and where the side wall meets the ceiling. They're not going to intersect because they're separated by the height of the wall. Okay, but the drawing looks like if I just extend it right there. So be careful with the drawings, all right, and the meaning. There's only one type of planes that do not intersect. Planes that do not intersect have to be parallel planes. It's not possible to have skew planes. The infinite nature of planes extending in 2 directions. The only way to, parallel planes. They have non-intersecting planes is for them to be parallel. We talked about this in the first unit. We tend to draw the planes just kind of like one on top of the other on the paper with a little space in between. And you're supposed to imagine that that's like the ceiling as a plane and the floor as a plane, separated by the height of our walls. A line that intersects 2 or more coplanar lines at different points. So elementary school, this is what you saw all the time. Mark these parallel, even though your teachers didn't mark them parallel in elementary school. Thank you. I don't have Junah right now. She's actually in my 7th. So they looked up the wrong schedule. What you're going to see more of this year, because this works for any 2 lines that you manage to intersect, this is a transversal. It doesn't matter whether the lines you're intersecting are parallel, intersecting, perpendicular. Any line that intersects 2 other lines is a transversal, no matter how strangely we draw the 2 lines to begin with. It's a pretty strange way to draw them. So. 2 angles that occupy corresponding positions, corresponding angles. Okay, so let's start with one from elementary school. Parallel lines cut by a transversal. Mark your lines parallel. And these 2 would be corresponding. And in elementary school, you learned corresponding angles are congruent. What I'm telling you today is not always. Okay? Because Going with my funky example here. On top of the line and to the left of the transversal. On top of the line and to the left of the transversal. Those two angles are still corresponding. What matters is the position. Okay? And I personally, especially when I do not have parallel lines, when they're doing weird things with the diagram, I highlight my transversals. Highlighting my transversals really helps me with the position of what's going on. So literally, I could do below the line and to the right of the transversal, below the line and to the right of the transversal, and the two I just marked in green are corresponding. It's the position that matters, not the angle congruence that matters. Still corresponding. Okay, two angles that lie on the outside of two lines and on opposite sides of a transversal, alternate exterior angles. So let's go back to the elementary school example. Mark your lines as parallel. Right, we had alternate exterior. And in elementary school, you were told alternate exterior angles are congruent, and now I'm telling you, not always. Okay, these are because my lines are parallel. Right, but if I draw the funky ones, and I am going to highlight that transversal, which makes my life a little clearer. So, out above the first line and to the left of the transversal, below the second line and to the right of the transversal, and they're not necessarily congruent. Two angles that lie on the inside of two lines and on opposite sides will be alternate interior. So what do you think? Sometimes, always, or never congruent? Sometimes, okay? They're congruent if your lines are parallel. They're not always congruent if your lines are not. So elementary school example first. Make sure you mark your parallel lines. Those are examples of alternate interior. Inside or between the parallel lines and on opposite sides of the transversal. Much more fun when you've got random lines. Like that. Okay, so below the line and to the left of the transversal, above the line and to the right of the transversal, not necessarily congruent. How many pairs of corresponding angles do you end up with when two lines are cut by a transversal? 7? 4? 4. There's always 4 pairs. How many pairs of alternate exterior angles do you end up with when two lines are cut by a transversal? Jonathan? 2. How many pairs for the alternate interior? Jenna? 2. Okay, the next set of lines, it really depends on your elementary school teacher, whether you saw them before or not. Some elementary school teachers do them, some do not. Consecutive interior angles. Some textbooks call them same side interior angles. Okay, and you do need to know both terms because I've seen both show up on the SOL. Consecutive interior or same side interior. If we go with the elementary school example, parallel lines cut by transversal, I'm talking about these two angles. Now, they were not congruent. Did anybody talk about these in elementary school? Okay, if you have parallel lines, consecutive interior angles are supplementary. But only if you have parallel lines. If you don't have parallel lines, then the relationship's really unknown without some information. I really like the lines that are parallel. They're more fun. It's just harder to see it. Now, I see alternate interior just fine when my lines are parallel. But when my lines aren't, it's harder to see it. Alrighty. So let's take a look here. I have a hexagonal prism trying to give an idea of 3 dimensions. So these are representing 3 dimensions to keep us going. So what line is parallel to line AG and contains point C? Andy?
Line CH or BH.
Has to contain C, which is right here. And I want to be parallel to this. So line C,
C.
I. Don't forget your line symbol. Okay. Perpendicular to AG containing point B. Sarisha? AB. Don't forget your line symbol. Skew to AG containing line C. Got more than one option for this one. Good call? CD. How about the second option? What else is going to work? Coming back, anybody find the other one that is skewed to AG and goes through point C? Sarisha? CB or BC, because we put the letters in alphabetical order. Okay. What about a plane that contains point C and is parallel to plane AFL? Brandon? Perfect. Plane CDJ. Make sure you've written out the word plane. Okay, you could have done CDI, CIJ. You had some options. The 3 letters. All right. No geometry lesson is complete without some theorems or some postulates. Yay! So we have 2 today. First one is the parallel postulate. If there is a line and a point not on the line, there is exactly one line through the point parallel to the given line. So in other words, we have a line and a point not on the line. There is only one way to draw a parallel line through that point and make that happen. And when you do constructions, you will actually draw that. The perpendicular postulate says if there is a line and a point not on the line, so same basic setup here, then there is exactly one line through this point that is perpendicular to the original line. Alrighty, I didn't give you parallel lines, did I? No, it's no fun for me if I give you parallel lines. I am going to highlight my transversal, because it makes me visualize things a little better. I want all pairs of corresponding angles. You already told me there's going to be 4 pairs here. So, what's one pair of corresponding angles based on the numbers I've got up there? Kevin.
1 and 5.
1 and 5. Angle 1 and angle 5. What's another pair? Sarisha. 4 and 8. Third pair. Hayden.
2 and 6.
2 and 6. Last pair. Liz?
3 and angle 7.
Angles 3 and 7. Okay. All pairs of alternate interior angles, you've already told me there's always 2. So what's the first pair of alternate interior? Jonathan?
Angle 3 and 5.
Angle 3 and 5. Okay. So inside, between the two lines I didn't highlight, but one has to be above, one has to be below the transversal. What's the second pair? Matthew? Angles 2 and 8. Okay. All pairs of alternate exterior, and again, you've already told me there has to be 2. Sarisha? 4 and 6. What's the second pair? Vibha? 1 and 7. Okay, consecutive interior, there has to be 2 pairs. Will? Angle 3 and 8. And the next pair?
Angle 2 and angle 5.
Angles 2 and 5. Okay. These lines appear to be parallel. Are they marked as parallel? No. So are you going to be able to assume they are parallel? No, because I've already told you that I am very fond of the Miss Levy diagram, right? Okay, now we're just naming angle pair relationships, so this is the vocabulary. This has nothing to do with measurement. But what's the relationship between 9 and 11? Devin?
Alternate interior angles.
Excellent. So ALT, INT, angle symbol apostrophe S. Standard abbreviations are a beautiful thing. What about 6 and 10? Vibha? Corresponding. CORRES. Angles. What about 8 and 11? Andy?
Consecutive interior angles.
Excellent. Consec. Int. Angles. And 7 and 13? Liz? Alt. X. Angles. Make sure you're making your angles plural. Okay, whether you're writing out the word angles or whether you're doing the abbreviation with the symbol, because you are talking about more than one angle. Alrighty. And now that you've learned how to do proofs, no geometry lesson is really complete without a proof either. Yeah. Alrighty, so we are given that the measure of angle AEC, I'm going to mark that, AEC, is congruent to DEB. Prove that the measure of angle AEB equals the measure of angle DEC. Fill in the blank proofs. Not my favorite, but what's missing in statement 1? Catherine.
So the angle DEB.
Excellent. The rest of my given. Measure angle DEB. Now they tell us we're going to use angle addition postulate to say the measure of angle AEB plus something will equal the measure of angle AEC. So what do I have to add? Peyton?
Oh, the measure of angle
BEC, is that what you said? Okay, good. Alright. Now they're telling us to use substitution. So the measure of angle AEB plus the measure of angle BEC. And I have to replace this with something. What am I going to replace the measure of angle AEC with? Sarisha? Yep. Now they're telling me go back to angle addition postulate. Measure of angle DEC plus measure of angle BEC will equal measure of angle Andy?
DEB.
Yep. Now they're telling me to use transpose. Ooh. So right here, these are equal to each other. So I'm setting these two statements equal to each other. AEB plus BEC. I'm going to say CED plus BEC. Because right here, I really prefer for that to be BED. And this one too. And I wish your textbook was better about putting things in alphabetical order, but they're not. Wow. So how did they get step 6? They did the work, they didn't tell us the why. Kimberly?
Did your subtraction property of equality?
Sure did. Oh, goody. This is the exact same proof. But we're going to look at it in paragraph form instead. So, they started off by saying, oh, wow. They started off by using angle addition postulate. They didn't even start off with their givens in this paragraph. By the angle addition postulate, we have two angles that add up to angle AEB. We have angle AEB, and we have angle BEC. Using substitution and given the fact that the measure of angle AEC equals the measure of angle, I'm going to say BED, putting the letters in the correct order, we can conclude that AEB plus BEC equals the measure of angle, I'm going to change that to BED to make myself happy. Now they wrote a compound sentence here, right? They put a given and a step together in a compound sentence, which you can do. Simple sentences tend to be easier, but you can do it. Using the angle addition postulate and the transitive property of equality, that is bad. This right here, sloppy, and your textbook does it all the time. Okay, angle addition postulate needs to be one whole sentence. Transitive property needs to be a second sentence. You're using two properties. Putting a property with a given, okay. But putting two different reasons together, bad. Okay. You can show that AEB plus BEC equals BEC plus CED. It follows from the subtraction property of equality. BEC. when you are looking at proofs in your textbook, be aware that they are frequently very sloppy with procedure. Yes, sir, Conley.
If the points are supposed to be listed in alphabetical order, should the first two be A, B, and C?
The vertex is always in the middle, and the two outside letters should go alphabetically. Okay. The other thing to be aware of when you're looking at proofs in your book is they call everything a reflexive property, even when it's symmetric. Okay, so as they are doing their work, they always list reflexive, even when they use the symmetric property. So your book has a ton of flaws. Just be aware of that if you're using your book as a resource. Exact same proof, but this time in flow format. Okay, giving you an idea of some of the differences here between the three. Right, starting off with our given. Measure of angle AEC equals measure of angle BEB. Picking up our angle addition postulate, measure of angle AEB plus measure of angle BEC equals measure of angle AEC. And these two ideas come together for substitution. We pick up angle addition postulate again and take our two statements to come together in transitive. And then finally we use our subtraction property of equality. Sometimes the visual of a flow proof is very powerful. These two ideas took me to this point. These two ideas took me to this point. And then I'm able to continue. I think that's it except for your summary, am I right? Okay, so now one of the things that I noticed grading binders, I'm going to flip back here to the beginning of the notes, is that some people are still struggling with where to put questions. Okay, on the first page, that column is full with vocabulary, or at least in this section. And then here, you've got a section, so there should be a question, and a question, and a question. Now it happens that this is a continuation from the previous page, identifying angles, so you would not need a question here. And then the rest of this is proofs, comparing and contrasting the three different styles of proofs. So the rest of this, no question necessary, no question necessary, and then of course your summary. You can always write more questions than the minimum. That's a personal choice. Okay, but that would be my minimum expectation. So